Hello and welcome to the course Industrial Robotics, Theories for Implementation. Robotics is an ever-evolving subject, and even after almost a century of its inception, it is still considered as one of the latest in engineering. This is probably due to the continuous enhancement in the robot capabilities owing to evolution of supplementary sciences like AI, ML, machine design methodologies, material science technology, real-time computing and processing, mathematics and algorithms for solving dynamics and performing controls, ruggedized hardware controllers, compact embedded electronics, fast industrial communication, precise sensors, compact powerful actuator technologies, etc. All the above needs to fulfill the ever-growing market manufacturing demands that have always kept robotics in the forefront to push any industry beyond the capabilities which it can achieve using any traditional machines. Hi, I am Dr. Arun Dayal Uday, Assistant Professor in the Department of Mechanical Engineering, IIT ISM Dhanbad. I am teaching subjects like robotics, mechatronics, CAD, automation for the last 14-15 years now. I have learned robotics mostly by implementing the theories that I have learned during pursuing my masters at BIT Mesra and PhD at IIT Delhi as regular courses or while handling the projects for my research. Currently, I make robots for various industries, academic universities and R&D organizations through my startup company called Aduza Robotics and Automation Private Limited, which is incubated at IIT ISM Dhanbad. I will be teaching this course along with my PhD students who are assigned as TAs for this course. They will be primarily helping me to prepare the practical demonstration to make you understand the various concepts that are taught in this course by implementing different technologies which are used in the industry. This course is designed for students who intend to have a systematic theoretical understanding of modern industrial robots, which are taught largely as an undergraduate course or a postgraduate course as an elective course. Students mostly seek to implement robotics know-how to develop prototypes for their UG PG projects, competitive events or for their research. This course would also be beneficial for learners from any industry who seek to understand the underlying concepts of industrial robots on which they might be working for years now. This will assist them to select a suitable robot for a given application, designing or modifying a robot for a suitable task, or to use a particular robot to its full potential. It has been observed that students or hobbyists are already doing well as an amateur robotist, where they are using low-end microcontroller boards like Arduino or Raspberry Pi, inexpensive servo motors, DC motors, express drivers, brushless DC motors, ESC controllers, or various MEMS sensors like ultrasonic range sensor, accelerometers, gyro magnetometer, etc., etc. They are also using SMPS and cheap jumper wires or connections, which are primarily the cause of failures for their projects most of the time during their school days, or even they are carrying forward and using it still during their first year of undergraduate course at least. However, the same should now graduate to a more professional robotics developments that use ruggedized and more reliable industrial substitutes for actuators, sensors, controller, power supplies, connectors, wires, etc. This course uses industrial PC or a PLC, HMIs, industrial input-output modules, industrial communication channels, industrial gate actuators and sensors, and industrial robots to demonstrate the concepts taught in this course. This course is expected to elevate the entry-level undergraduate or postgraduate students to devise professional solutions to robotics challenges that they may face during industry or in their research. Parallel robots, wheeled mobile robots, which are used by warehouses or autonomous vehicles, aerial vehicles, UAV or drones, space robots, underwater robots, humanoids, domestic service robots, etc. will not be covered in this course. However, The principles taught in this course are also applicable for such robots. We'll be doing only industrial serial arms, commonly known as manipulators, or we'll call it as industrial robots from now on. The prerequisite for this course is very basic and is mostly taught in the first year of engineering syllabus. One should be familiar with linear algebra, mostly vectors and matrices, calculus, mostly differential equations, engineering mechanics and trigonometry. Python with ThinQuat ADS library will be coded on industrial PC with HMI to communicate to different input-output cards and motor drivers. Hence, having a basic know-how of Python programming will be a definite plus for this course. I shall be referring to various references such as textbooks, manuals, literatures, robot manuals, data sheets which one may refer while covering different modules of this course. The learner should be able to build a theoretical concepts of robotics after graduating from this course. The learner should be able to build theoretical concepts of robots, apply the robotics know-how in the industry using a standard set of robotics hardware, understand the principles involved in regular functioning of any standard industrial robot, analyze any given problems and suggest a possible solution, evaluate the problems associated with robotics, robot kinematics or dynamics. The course is divided into 12 modules that will be covered in almost 12 weeks in around 30 hours of video lectures. Spread across 12 modules, one will understand various important terminologies that are necessary to work with any industrial robots or even to talk with any industrial people who are working with robots. One will learn about various actuators, sensors, associated hardware. We'll be demonstrating industrial actuators and sensors and its working using industrial PC and IO cards interface through industrial communication protocols. Kinematics, statics, dynamics and controls of industrial robot will be covered just like a regular part of any standard UG/PG curriculum of robotics. Apart from these traditional know-how, this course includes unique modules such as installation and commissioning of newly procured industrial robots, calibrating the robots and effector tool, linear rails, workpieces, work surface, turntable, load data, and ISO certification tests such as repeatability calculations, etc. And yes, all this will be done with a reference to real technical data sheets, user manuals of industrial robots, and a demonstration of various concepts will be carried out using real industrial robots. I am excited to teach this unique course. I hope you are excited too. So without any further delay, I wish you a very happy learning. See you all in the lecture classes. Thanks a lot for opting for this course. Thanks a lot.